Okay, I corrected the error that I had here, because should have been this times k. So as I was explaining, a vector that's a j plus something times k, well, j has magnitude 1, so the run is 1, right? And the rise is whatever you multiply by k, which is this, right? So rise divided by run for this vector is just partial of f with respect to y, right? And that is the slope. Okay? So the slope is the slope, so this has to be a vector, excuse me, in the direction of that little tangent segment, okay? Similarly, this is a vector in the direction of this tangent segment, right? So if I have two vectors, they're both tangent to the graph of the function, aren't they? This one's tangent to the graph of the function if you confine it to a plane parallel to the y-axis, and this if you confine it in a plane parallel to the x-axis. Both of these vectors have to be tangent, assuming the surface is smooth and has a tangent. These vectors are both tangent to it. Okay? We'll make this a little more rigorous, but intuitively that should click. So that if I take the cross product of these, as you did when I asked you to measure that, did I ever actually to measure the thing that I gave you? I don't think so, because it took me so long to remember to cut it out and bring it. Okay? Well, if you were to measure it, you'd be able to figure out the slope in this direction, the slope in this direction. Okay? You could find then a vector in this direction and a vector in this direction. I did have you do that with calculations. I gave you a function, asked you to plug in, get the dimensions of this thing, and analyze it, right? So you've done that, so you've got that back. You should maybe review that, but I think you understood it. Okay? So you get those two vectors and take their cross product. Now you've got a normal to the plane, and now we've done normals to the plane and equations of planes, so you can find the equation of the tangent plane, right? Okay? So we're 2/3 of the way through chapter 4 already. We just started. Well, there's some details to fill in. Okay? But that's your tangent plane. So there's your definition of partial derivatives. So that's what they mean. This is what they look like, or at least how you can visualize them. And this is one use you can make of them. And a very important use, because tangent planes are really, really, to the 14th power, really important. Okay? Okay, make sense? This whole picture, you should, from what we've done and from what we did in the first week, this should all make really good sense to you. If it doesn't right at this instant, of course, because the Doppler effect is in effect, the phenomenon whereby stupid ideas seem smarter when they come at you faster. They're coming at you pretty fast right now, okay? So maybe you haven't totally sorted it out, but if you stop and think about it and do what you're supposed to do, if you have time to do what you're supposed to do, I understand that, then this ought to click very, very well.